Hello class, welcome to lesson 3-1, day 2. Said strong mathematicians can divide with remainders and use multiplication patterns to divide with zeros. So we're going to focus on that second part of the day about using multiplication patterns to help us divide with zeros. So take out your notebook, your pencil, write down today's date, the name of the lesson, and let's begin. So we don't have to write these vocabulary words down because we've seen them before, but just to remind you, the divisor, the quotient, the dividend, and the remainder, those are all division terms that we see when we are doing word problems and solving these problems. And now here's kind of the difference today where kind of how the division word problems and how they get related to multiplication words. So the factor in multiplication, the 3 and the 4, are the divisor, which is what we're dividing by, and 4 is a quotient, which is our answer. And then the product is the dividend in a division problem. So in a sense, they're the same thing, but when you do different operations, they have different vocabulary words that go with them. So we're going to make sure we keep those words in our mind and fresh, we know what words we're talking about. Here's something that I do want you to write down in your notes today is that we can use the inverse operation of multiplication to check your division problem. Just like in addition, we were able to use subtraction, and if subtraction, we can use addition. In multiplication and division, we can use multiplication to help us out. So notice we have this problem, 7 divided by 39 equals 5 with the remainder 4. The 4 equals a yes because the 4 is less than 7. So here's how the strategy works. You're going to multiply your divisor and your quotient. So you're going to take your divisor of 7 and your quotient of 5, and you're going to multiply those together because this means I can get 7 groups of 5 from 39. Which gives you 7 times 5 is 35. The big thing is now your remainder is what's left over. So we have to add each of those to it, our 35, which gives us an answer of 39. So notice our 39 matches 39 right there, which means my answer is correct. So you can pause the video right now. You can write down this strategy right over here to help you out, to show you how to make sense of a division problem and how to check your work with multiplication. So here we are today, some examples. We're going to solve our work and we're going to check with multiplication. So how many times can 9 go into 41? Well, I was thinking of what is 9 times 5. They're always in the middle. 9 times 5 is 45, so that is too much. So I'm going to go with the 4, but it's pretty close. So I'm going to go with a 4. 4 times 9 is 36. And 41 minus 36 is 5. 5 is less than 9, which is good. So my remainder of 5. Now I'm going to check my work with multiplication. So what do I mean? I'm going to take my 9 times my 4. So 9 times 4, using my finger strategy, which you can't see, but I get 36. And now plus my remainder of 5, which equals 41. Notice 41 and 41 are equal, so I know I'm pretty confident that I got this problem right. The next one, how many times can 3 go into 22? Well, 3 times 5 is 15. That's pretty far from 22. 3 times 6 would be 18. 3 times 7 would be 21. 3 times 8 would be 24. That's too many, so we're going to go with 3 times 7. 3 times 7 is 21. 22 minus 21 is 1. I look, 1 is less than 3, so I can't have any more groups I can take out. So my remainder is 1. Now I'm going to check again with division or multiplication to check my division. 7 times 3, taking my divisor and my quotient, gives me 21. I'm going to add my remainder to it because that's what's left over to give me 22. Notice 22 and 22 match up. So I'm pretty sure that 7 divided by 2 is 7 with a remainder of 1. So you can pause the video right now and write down these examples to help you out with your work today. So now we're getting to these bigger problems. Like I said, 9 divided by 3,600. I'm thinking, wow, it's a big problem. But we can think about using multiplication. Well, 9, and I'm not going to worry about the zeros. I'm thinking about 36. Well, 9 times what would equal 36? Well, if I use my finger strategy, 1, 2, 3, 4. I have 3 on this side, 6. Oh, so it's got to be 4. 9 times 4 equals a 36. But notice there are 2 zeros, so that's going to be 400. So now how does it look in division? Well, 9 can go into 3. Nope, it can't go into 3. Can 9 go into 36? Yes, it can. That would be the 4. And then 9 times 4 is 36. I subtract, I'm left with 0. Well, there's a 0 here and a 0 here. So really there's nothing left. So this would be a 0 in the tens and a 0 in the ones. Notice these two answers match each other, because 9 times 400 is the same as 9 divided by 3,600. So I'm thinking the same thing now, but I'm going to do the division problem first. 7 can go into 56. Well, 7 times 5 is 35. That seems like a far way off, so 7 times 6, if I add 7 to 35, is 42. Nope, I can go higher. Let's see, 7 times 7 would be 49. That's pretty close. What's 7 times 8? Well, if I had another 7 to 49, that would be 56. Wait, 56, there it is. So it's not above the 5, because 7 doesn't go into 5 8 times. 7 goes into 56 8 times, so it goes over the 100 place. 8 times 7 is 56. I subtract, I get 0. I get another 0 and another 0, so there's nothing left, so I can't just leave it. I got to put a 0 here and a 0, because each of these 10s and the 1s are a place value. So what is 7 times what equals 56? Well, we know that's 8, but now I've got a 0 and a 0, which would mean it would be 7 times 800. You can pause this examples down right now and add these to your notes. So that was nice that they ended in zeros, but what happens when they don't end in zeros? How am I going to solve this problem? Well, I'm going to do that same type of strategies, except we're going to talk about some of the things with what do we do next? So can 6 go into 4? The answer is no. 6 cannot go into 4. But can 6 go into 42? Yes, it can. So I'm going to start right here in my hundreds place value. So 6 times 5 is 30. So 6 times 6 is 36. 6 times 7 is 42. Wait, 42, that's an exact match. That's good. 7 times 6 is 42. I'm going to subtract, get 0. And I'm going to bring down the 0. Well, I don't have anything here to divide, so you put another 0 in my tens column. I'm going to put this 5 here. Is 5 less than 6? Well, yeah, so I can't do anything, so I'm going to put a 0 here, which means my remainder is then 5. I can do the same thing. I could check my work by using multiplication, and that would work as well. So you pause this one. This is another example of now dividing with zeros. So now it's your turn to try to solve and check with multiplication. So your numbers are 21 divided by 4 and 47 divided by 7. So you can pause the video right now. So you're going to try to solve them, and when you're done, check with multiplication to see if your answer is correct. Here's some more problems to do. Now we get into a little bigger numbers. 3,200 divided by 8 and 5,400 divided by 6. See how those numbers relate to multiplication problems. How you go forwards and back from one to another. So pause the video right now and give them your best shot. And last but not least, another problem. Now it takes the zeros out and throw some extra numbers in there. What is 3,203 divided by 4? Pause the video, do your best, and look forward to seeing a picture of all your work from the Now Your Turn. As always, if you have any questions, comments, or concerns, feel free to share them out or write those down. Also, if you have any strategies that you use to help you, make sure you include them in your comments. That way we can help each other learn how to become better dividers. Thank you for another great lesson.